Hi everyone. In this video, I wanted to give a quick demo of a debugging tool that my partner and I have been working on called memshonk. The main problem we wanted to solve with this was that a lot of debugging tools are very GUI heavy or they're tied to a specific environment, and that becomes a pain when you're working across different operating systems or you're debugging over SSH. And so we built memshonk as a terminal-based tool to fill that gap. It's currently supported on Windows, Linux, and FreeBSD. And I'd like to think of it more as a debugging companion rather than a full debugger. It's meant to work alongside tools like GDB and not replace them, at least for now. And just a quick disclaimer that this project is still in its early stages. We're experimenting and trying new ideas and building things out as we go. I'll link the GitHub repo for memshonk in the description, and within the README you'll find instructions on how you can compile it yourself. But to start with the demo, I'm currently in a directory called memshonk, where I have a compiled memshonk.exe. I'm going to run it with winpty, which will help make it look and work nicer within the Windows terminal. And I'll give it a -h argument just to list out my different options for arguments I can provide it. You can give it a -e and then an executable file path, or a -p and then a project file path. I have a project file path ready. I have a project file under examples, and it's called vim-windows.txt. If I click enter, memshonk will start, and I'll see some logs of connecting to daemon, and then you'll see the blue prompt. This is the memshonk prompt. What's within the braces, which is remarkable-leopard, is my session name. And so what I have in this window to the left is I've started a Vim process, and I want to debug it using memshonk. I've specified the Vim executable within the project file, and so all I need to do is type in attach, and you'll see the log attached to vim.exe, a PID, and a base adder. What you'll see next is that the memshonk prompt changes to include the PID within the prompt. From within the memshonk prompt, you can type in the command help to see a list of the available commands, as well as you'll also see a list of topics. To see more information about a topic, just type in help and then the name of the topic. So let's try out the command find, which searches the process's memory for a specific value. What I'll do is within Vim, I'm going to type in sharks are cool. And now within memshonk, I'm going to search for that string. So I'll type in the command find. I can do -h to get information about how to use find. I'll do find -d, searching for a string, and I'm searching for sharks are cool. Press enter, let that search, and what it did is listed out the addresses of every time it found string sharks are cool in memory. To confirm the results of find, we can use another command called readm for read memory. We can provide it a -a, which stands for the address to read from, and a -s, which is the number of bytes to read. The output will default to showing in a hex dump style view, where the first is the address. These are the hex bytes, and then to the right is the human readable characters. And we can read sharks are cool. Another command that I want to show is the watch command. So watch lets you watch a certain range of memory, and then you can watch for changes as they happen. So the first argument you give it is the number of bytes that you want to watch, and then the next is the address you want to watch at. The cool thing of watch is that you can provide one or more addresses. So I'll provide all of the results from the find from earlier and press enter. And what we see here is it's currently watching 15 bytes at all of those addresses. If I were to change any of the text in the Vim process, you can see how these addresses values change in the right. Some change to the new text, some don't change at all. And so all of this can help with investigating as you're debugging. I wanted to highlight that memshonk is a full shell-like environment, and so you have access to useful features like tab completion or shell history. You also have the ability to search through your previous commands, as well as you have access to external programs. So if I did the memshonk command via map, which lists out all the memory regions, it can be a lot to parse through, so you can always just pipe it and use grep. And if I only wanted to see memory regions that are read-write, I can grep for RW, or I can grep for RWX. There's only one result there, but you can see how that's useful to filter down that list. From within memshonk, you can cd to different directories. So I can cd up a directory. Within that directory, I can create files. I can cat those files. And I can do this all within the memshonk prompt itself. So this is useful so you don't have to keep switching programs. It can all be done within memshonk. So I wanted to provide a bit more of an advanced shell example. So with the results of find, if you get a bunch of addresses and you want to write to each of them, instead of doing it each individually, you can utilize using for loops in the shell. And so I have a for loop here that will first, with each address returned from the find command of searching for sharks are cool, it will write at each address the value whales. If I let that run, what also ends up happening is it overwrites the value seen in Vim. Sharks gets replaced with whales if I refresh it, as you can see. And so it wrote to each of these addresses, and that can help a lot with automation and saving some time. One of our favorite features of memshonk is that we support having multiple sessions connected to the same debugging project. This want originated from using other debuggers like GDB, where as we'd use it, we'd really wish that we could split up the windows, have different windows doing different things or looking at different things at the same time. And this was a big reason why we felt strongly that memshonk should be a terminal application. This allows us to manage our sessions easier. It allows us to have sessions over SSH and for us to have tasks running in different windows at the same time and to keep it managed and organized. So I currently have a memshonk session running in this top terminal. If I do the command session ls, that lists out all of the sessions for this project. Currently there's just this one, which is us, Remarkable Leopard. If in the bottom terminal I also connect to that same project, this one I will specify my session ID as Hello YouTube. I'll start memshonk and you'll see the memshonk prompt. If I do session ls in the top again, you can see that my session Hello YouTube is listed under the sessions. So sessions are managed in memshonk using a client-server relationship. There is a server memshonk that's created once the first session is created, and then now when any new sessions are created, they connect to that same memshonk server. As an example of what you can do with multiple sessions, in this top memshonk session, I did the find command again to find the string sharks are cool, and I have a few results. In this bottom memshonk session, I'll do the watch command, and I'll watch 15 bytes at each of these addresses. Next, in this top memshonk session, I can do the for loop that I did earlier, where I'll search and then get each of the results for the find of sharks are cool. And then at each of these addresses, I will replace the word sharks with whales. And we should see that result in the watch below. There we go. So I want to show a few more cool things about memshonk using a different example. I have the video game Mass Effect 3, and I have memshonk attached to it. Within Mass Effect 3, I have debug commands enabled so I can see my player's location. I can see the XYZ value. And so if I do a find, so I can search the process memory for those 3 float values, it can search sequentially for those values within memory, and it comes with a few results of a few different addresses where that's found. And that can help you narrow down, and you can play around with these addresses. And I figured out that one of those addresses is if I adjust the value at that address, it actually changes my player's location in the game. And I'll demonstrate that with this write command at one of the addresses. And hope you saw that. My character moved to a different X coordinate because I've written a new value there. In another popular debugger called Cheat Engine, there's a concept of pointer chains, which is a base address and then a series of offsets that lead to different pointers that then lead to a specific memory address of interest that may hold something like the character's ammo or health value. In memshonk, we support a way to describe these pointer chains so that you can read and write to these values. So this is how you describe it in memshonk. This is the base address and then a colon, and then the series of offsets are separated by commas. And so what this pointer chain describes is the character's ammo, which is 49. So if I read from that pointer chain, I get 49. And then something fun I can do is I can write to that pointer chain and then give myself, let's say, 999 ammo. So a feature we added into memshonk that I had trouble finding in other debuggers was that I wanted to search the process's memory for a certain pattern of bytes. We support this with the find command, where you can specify a pattern of bytes that you'd like to search for. So here I specified some certain bytes that I'd like to look for, and then I can use question marks as placeholder bytes, which are wildcards, which can hold any value. And then I want my pattern to end with some FFs at the end. Once I run that find command, it'll result and give me a list of addresses where it found that pattern. This feature was useful to us because I noticed that in the video game, all of the location information of each of the enemies started with these bytes and then ended with these bytes. So if I could find all the addresses where we found this pattern, I could find where each enemy's location information was located. One of the major features we built into memshonk is a plugin system. And so the idea is that you can write your own plugins in Rust, and then you're able to extend the functionality of memshonk without you having to modify the memshonk code itself. It uses dynamic libraries so that you're able to load and reload plugins into the memshonk program while it's currently running. This makes it really flexible for you to be able to add your own custom commands or your own tools into memshonk. We've created our own plugin for Mass Effect 3, and so if you've loaded memshonk with a plugin, you can run the command plugins and it'll list all of the current plugins. There's one we have called ME3. I can do ME3 and -H, and there's support for some usage information. And then we had some fun with it. We made a command called geese spin. Once I press it, it makes the enemies in the game spin around in the sky. Whee! So that'll be it for the demo. Thank you so much for watching. There's a lot more to memshonk that I couldn't share, but if you have any questions, you can leave them in the comments. Thank you very much.